We mastered fixed statement for targeting specific data subsets. Now let's add another layer of control: if statements and conditional logic. Together, fix and if gives you the ability to write scripts that not only targets the right data but also apply the right logic based on what the data contains. Think of if statement as a business rules engine inside the Essbase script. Instead of applying the same formula for every cell, you can test conditions and execute different logic based on the result. This is essential for real-world financial models where rules vary by scenario, by value, or by business conditions. So let's understand the basic syntax of if statement. So it starts with keyword if. Inside the bracket, we'll write a condition. If the condition is true, it comes inside and execute the calc. Then ENDIF. This is a simple if syntax. So if we need a logic to execute if the condition fails, right? So there we'll write else calc. So here what happens, this calc will get executed if the condition is true, and this calc will be executed if the condition false. Let's look at the sample example. So we have a business requirement to check if sales is greater than 1 million, then trigger a bonus calculation, or else handle the standard case. So here if we see, we are checking the sale is greater than 1 million. If it is greater than 1 million, then we are calculating bonus by 20%. Only if this if statement is true. If it is false, then it comes to else. In case this fix if statement is false, it comes to the else statement and calculate the standard case. That is, by default, the bonus will be 10%. So imagine we are calculating sales commission with slab rates. So what exactly it means? If sale is under 100K, then bonus should be 5%. If salary is greater than 100K and less than 500K, then bonus should calculate based on salary of 8%. And anything above 500K, my bonus should be salary into 10%. So this shows the nested if statement. So the advantage here is when this becomes true, this condition becomes true, the first condition becomes true, it will never ever check for ELSEIF or else for that particular loop. Okay. If the second if becomes true, then it won't even go to the next steps. This is one advantage. So there is another way of writing this script as well. I'll show you that. So this is another way of writing the if statement. So what is the major difference? If you can see here, after every if, I have written ENDIF, right? Every if I have written ENDIF, but my looping structure is same. Forecast working FY26 Jan to December. But my checking of condition bit varied. So what happens here is, in my first loop, if my salary is less than 100K, it enters here. Same thing happens on the left side as well. If my salary is 100K, it executes this 5% bonus. Same thing is happening here. But in the next, what happens when once this get executed, it's completed, again it checks for this if condition, for the second if condition. Whether it is true or false, it doesn't matter, because this is a separate if condition. This is separate if condition and this is another if condition. Same thing applies to the third one as well. Even if the condition satisfies here, it still checks for the if conditions here. But here it's not the case, because we have else if. Only if this is false, it comes here to the else and check for this condition. But on the right hand side, whatever the case, whether it's true or false, it always check all the if conditions. Here there will be a major performance impact because it checks each and every condition for all the loops, right? So we need to be very careful when we are declaring the if statements. We need to zero in what is a business requirement. So based on the business requirement, we need to design the script. So when we validate or save this calculation script in a calculation manager, when we click on the save button or the deploy button, Essbase will parse the script, the entire script. It checks for a syntax error, verifies whether that member exists in our outline, and maps out an execution plan. So when we save this particular script, the Essbase engine will check whether these metadata or these members are present in our outline. If it is not present, or if we do a typo here, instead of bonus, if we write bonus with extra s, when we click on save or deploy or validate, it will throw us error telling that this member is not found in the outline. So we need to be extra cautious while writing a calculation script. So however, if conditions are evaluated at calculation time, at runtime, so here if conditions are not checked or not parsed when we save the calculation script, it is checked when the script is getting executed. So Essbase spins up the loop over the data block defined by the outer fixed statement. So whatever fixed statement we have here, the forecast working FY26 Jan to December, each loop it will get its respective block. For example, forecast working FY26 in the first loop we have Jan. So we get a block for this combination, and for that particular combination, the blocks, it checks whether the salary is greater than 100K and it calculates accordingly. For every single data block that meets the fixed criteria, Essbase pauses to evaluate the condition inside your if statement. So if your fixed scope contains 100,000 blocks, that is 100K blocks, Essbase will evaluate that if condition 100,000 times. If we have nested another if inside it, the performance penalty multiplies. As shown previously, this script has nested if without else. So every time it parses all the if conditions where the performance will get impacted. So this is why complex nested if statement causes calculation time to skyrocket.